Welcome to the session, Large Language Model. My name is Mustafa. I have about 15 years of experience in data analytics. I will be going to, today about large language models. I will be showing you how to use LangChain for large language models. I will be also going through many use cases. After me, Sarmad will be showing you some live demos on some of the applications built using LangChain plus large language models. And finally, Asif will be showing a real life use case using robotic process automation plus large language models. Okay, so this session will be around 40 to 45 minutes. Okay, so a little bit about us. We are based out of Chicago. We have been in business for about 20 plus years. We are an ISO certified company. We are about 1,700 plus people worldwide. So before I start, I mean, like, just to get a high level overview, and I have the mic out here. If you can just tell us what is your experience with, LLM or OpenAI or ChatGPT, and if you could ask a highly advanced generative AI model any question, what would it be? And can anyone share a quick fun fact about generative AI that they have recently learned or observed? So if we can just start with you, if you can just introduce yourself.
Yeah, thank you so much. My name is Semantic. I'm working in the World Bank. The data scientists there. Basically, we don't get more on LLM or something. I'm here just to be. That's what the company is doing.
Okay.
To look for
Okay.
partnerships.
And I mean, do you have any fun fact about generative AI that you have recently learned, which you want to share with everybody?
Not really.
Thanks.
Hey, thank you guys for having me. My name is Steve Berry. I know, sorry. Until very recently worked at William Blair as their chief architect. I went out and just joined a startup. I'm AI in compliance with a couple other professors, but I also have a night job at the University of Chicago where I teach the data science program. So happy to join you all. What's my experience with LLMs and OpenAI? I worked with it for a couple of years. I've worked with OpenAI forever, but LLMs I've worked with for a couple of years. I've sat in a few panels. I like talking about it. If I could ask anything of an AI model, I'd ask it when I'm in a town. A fun fact. I think I've got to pause on that one. Fun fact.
Okay.
But it's very good on the end.
Hi everyone. Thanks for staying us today. My name is Alex. I work for Northwestern Medicine's data engineering.
Okay.
I guess if I would ask highly advanced AI model, any question would be what are the use cases of in healthcare, some useful use cases for patients or for healthcare providers. And
Fun fact. Okay, that's fine. Yeah.
Hi everyone, I'm here with Citizens Bank, and my experience with LLMs, speak from the academic standpoint, I just finished a program at Cambridge on LLMs and implementing that at bank. In terms of a fun fact, about 2 years ago, we delved into the ethics of generative AI by using basically materials, whether it's images, visuals, lyrics, and we thought that it would be problematic if it wasn't properly licensed.
Yeah.
2 years, fast forward 2 years, we're really dealing with that entertainment project. Very much on the IP side of things too. So, whether it's law. So I think if I could ask a highly advanced generative AI, I would ask for, what should we be looking for further unintended consequences?
That is awesome. Yeah, that's a good question.
Hello, my name is Ekman Pat. I'm the founder of the Packable Small Digital Boutique Agency. My experience with LLMs and AI is, I would call it mostly AI curious right now with all the probably the Cambrian explosion of AI. I've been experimenting with it. I started a small YouTube channel of YouTube Shorts that the script is generated by AI, the character is generated by AI, the text to speech is generated by AI, the video is generated by AI. The only thing that's not generated by AI is a final production and assembly of a video. So like if I can close that loop, maybe I can just like auto generate a batch load of YouTube shorts. And I don't have a good answer, a question for generative AI, but maybe like what the future would be when the AI overlords rule us, and if they'll be kind overlords. Fun fact about generative AI that I recently learned. I used to have a podcast, so I was able to train a voice model of my voice, and it came out to less than 100 megabytes, so like 76 megs or something. And with all the podcast video, I trained there's a video model. I used that to train a video model of me. That came to be less than a gigabyte. So what's interesting is we can digitally clone a human without the brains, but just the voice and the imagery for less than a gigabyte. That's all a human is. That's
Great, awesome, great.
I thought that was very interesting. Kind of demoralizing isn't the word, but kind of like depressing. Like, oh, you can just clone a human for less than a gig.
Thank you so much. Thanks. Okay, so let me move on. So I think I know some of you are like familiar with the large language models. So large language models are voracious readers. So I mean, they basically read all books, all code, all blogs, all websites. Okay. So and what they do is that they try to build a statistical understanding of language structure. So let's play a game. I mean, how many people are familiar with this game? So if anybody wants to guess, another feather in your cap. Yes, absolutely. So I think that's what large language models do, right? Like, based on all of the reading they have, done, right? So they basically predict that what will be the next word or the next letter there will be, right? So this is the definition of large language models. So if I just go through the main point of it, it is learn from a large corpus of human written text, predict what words are most likely to come next, giving a particular context, which is determined by the preceding words in the text, right? So what are some of the shortcomings of LLMs? So just like Socrates said that you don't know what you don't know, right? So if you ask large language model that who won FIFA World Cup 2022, it will not know because the ChatGPT is just trained till September 2022, right? And then FIFA came later than that. So these are some of the top LLMs which are available. So starting from 2019, you have the GPT-3 came out in 2020. Then you have Bloom, which is open. So all the ones which are in yellow, they are basically open source. So if you just keep on going down all the way to 2023. So this year we have Llama by Facebook, Bard by Google, and some other commercial LLMs. So I think you might know this that Uber to gain 100 million user, it took them about 5 years, but ChatGPT got 100 million users in just only 2 months. So ChatGPT is pretty popular. Now, large language models are not just limited to just text. So, I mean, like, there are a lot of other models available like Bloomberg, Galactica, Image. So there are a lot of different LLMs available based on your use case, besides just OpenAI and ChatGPT. What on pricing? So the way OpenAI charges is based on 1,000 tokens. So 1,000 tokens is about 750 words. Uh, there are about on this slide, I have about 30 tokens, and GPT 3.5 charges here about 0.002 per 1,000 token. How many people have read the book War and Peace? So War and Peace has about 587,000 words. So if you want to train War and Peace on large language model, it will cost you about $1.56. The daily generated information volume is currently estimated to be about 328 million daily new data. So if you want to train ChatGPT on this, the processing cost will be about, I don't know how to read this number, but I mean, it will be pretty large. So if you see in 1990s, when Windows 95 came out, the data processing activities was the major hit, right? And then when internet came out, I mean, there were companies like Amazon and Google came, right? And then when in 2007, when the mobile phone came out, companies like Uber and other social media companies became really popular. Now LLM has come out, so you will see multi-billion-dollar companies will be coming pretty soon. But it is not about just LLMs. Like LLMs is being used by every single business. So here are some of the most important use cases. So it's starting from finance to marketing, customer service, HR. And Asif will be showing you today a use case with RPA and plus large language models. So he will show you a live demo of an HR use case which utilizes generative AI. Now, with all of the like use cases of generative AI, a lot of companies have banned uh, like usage of ChatGPT and sort of similars, like McDonald, Amazon, sorry, not Amazon, JP Morgan, PricewaterhouseCoopers. And the reason is not that they don't know the benefit of uh, ChatGPT. The reason why they have banned it because they don't know that the data when they are calling the OpenAI, API, and when they are calling that API and the data they are sending, is it secured or not secured? So these are the five things which all the different companies are really concerned about: the security, the privacy, the cost, latency, and then accuracies. So how do we handle these five things? So all of the companies have realized that they have saved about 40% of working hours in all of these verticals by using LLMs. So right, so the benefit of using LLMs in any verticals is really great. Um, so for enterprise to create value, generative AI needs to be tailored to the enterprise. It has to focus on the business value. It has to be open. It has to be the infrastructure and the large language models have to be agnostic, and it has to be secure and governed, and it should have the ability to fine tune according to your brand. So how do we do that? So currently we have three choices. All the enterprises have currently three choices. One is closed source. So in the closed source, you don't have the access to the source, but you can call any of these large language models utilizing the APIs. Then the second option is using the open source model. So in the open source model, you have these are a few of them, but there are a lot more. And then finally, you can build your own. So if you have a lot of data like Bloomberg, you can build a whole LLM yourself also. So you have three choices: close, open, and then build your own. But to create any LLM based application, you need a generative AI tech stack. So you need some basically the infrastructure foundation models, MLOps, API layers, and applications. So there is an open source AI tech stack to build LLM, and it is called LangChain. If you go to the LangChain community, you will. So LangChain is a open source Python library designed to assist in developing practical applications based on LLMs. Okay, so and within LangChain, you get all of these different submodules like chains, agents, prompt templates, retrievers. So all of these modules help you build an LLM-based application. Yes.
Quality of the code.
I think right now, Sarmat will be showing you a couple of them. I mean, so far we are very happy with it. Yeah, LangChain I would rate right now to be number one. Yeah, framework. So the good question. Yeah. So this is how the high level flow looks like. So when the user goes to any chatbot, I mean, it sends the query, it goes to a LangChain framework, and then LangChain uses different tools to basically connect to REST API or your data warehouse or to a large language model and also to the vector databases. So this is how the overall architecture looks like. So so this is something which you can build using LangChain. So we talked about the three options. Okay, the first option is build your own, and there are pros and cons to it. I mean, the pros are that it is specialized with high accuracy and confidentiality. The con is that you need really good data scientist people to basically make that happen. Second option is that there are a lot of large language models available, open source, so you can train one of the open source model and do that. And finally, the most fastest way to build an LLM-based application is to use something like OpenAI. So I will start with the third option first and show you that how you can build an LLM-based application with something like OpenAI. So now, if you go with something like OpenAI, the prompt and the response which you so the question which you will send to OpenAI and the response you will get back, it has to be under 4,000 limit. Now this limit is keep on growing up, but there is a limit to it. So if your prompt and response is more than 4K, then your application will fail. So how do you solve this? So now, if I currently go to ChatGPT and if I ask any question, it will reply to me back with any public data. But if I ask him, does Royal Cyber Health coverage covers vision? It will not know because that is a data which is inside our company, right? So this data is not inside the LLM, right? So how do I do that? So if I ask a question right now that does Royal Cyber coverage covers vision to LLM, it will just give me some hallucinated response. So how do I fix this now? So what we will do is that I will take all my data, like whichever I want from my company. It could be either my data warehouse PDF file, my SharePoint, my Salesforce, right, other things, and then I will move it to a vector DB. So we basically, and so what we will do is that we will take the data, and then we will convert that data to a vector, and then we will, store that data in a vector database. Now, what is a vector database, right? So conventionally, if you do a search, right, buying for seafood in a normal site, you will get no products found. But if you do the same search in a vector DB, buying for seafood, you will get some result back. So Google, I mean, uses basically vector DB. So why is Google so fast? Because it uses vector database. So how does vector data? Here are some of the vector DB which are commercially available. Like there is Pinecone, Vivian, Elastic, right? So these are all SaaS-based platforms. So you can just sign up for that and then start using it. And what it does is that it basically takes any structured or unstructured data from your company, and it converts it to a three-dimensional vector, and then it stores that vector in the vector database. So you can, consider it like a supermarket. So if you go to a supermarket, all the meat is at one place, all the dairy is at one place. So that is how vector database behaves. So coming back, so uh, what you will do is that you will basically take all of your the enterprise data which you want the ChatGPT to be used on, and then move it to the vector database. You can use any of the tools which you have. You might be using Matillion or Fivetran or any other, ETL tools. So you can use any of those out here. Okay, now once I have all the data stored in the vector DB, now if I ask a question, does my company health plan covers vegetables? So it will then get the right relevant documents from the vector DB. It will send the question and the document to the large language model, and then you will get the response back. So so out here we are just using the language facility of the large language model, and all the data is coming out from our vector database. Okay. Another option, which we have is training and, LLM. So there are a lot of open source available, and you can train, you can, get one of those models and then you can train it. And that training is called transfer learning. Now, for the transfer learning, you also need like somebody who has deep learning skills. And finally, the third option is build your own. So for building your own, you need this sort of stack. So you need NVIDIA, you need Kubernetes, Ray, you need all the deep learning libraries, and then you can create your own large language model. And it is a gigantic task, but you can, build your own. A lot of companies have, built their own LLM. So if one of the example is like Bloomberg GPT, so Bloomberg has like built their own. Another example is Biomed LM. It is also their own. And then I think this is something very important. So currently, if I go to any Walmart or if I go to Target, right? If I search for something like, oh, so sorry, if I go to like Home Depot, right? And if I search for PVC plumbing irrigation system, it will not work, right? Because it is based on keyword search and not, NLP. So you want to go from here to tomorrow. You can do a search like what material, less and tools do I need to build an irrigation system for my 1 acre backyard in Detroit, Michigan. And it will give you the right result set. So how do you go from here to here, right? So for that, you need that LLM, stack which I just showed you. Another use case which we have seen a lot, which companies are doing, if I go to my SharePoint or something else, my portal, and if I search for 401k policy USA, it will give me a random, documents. But if I want to search something like what are the key aspects of the company's foreign employee in my location and how do I enroll, it will not bring me the right results. So if you want to go from here to here, you need to implement the semantic search. I think that was a high level overview. I will now give it to Salman. I mean, he will give you a quick demo of some of the applications using LLM. And yeah.
Thank you so much, Mas, and thank you everyone for joining us today. Right. So over here, whatever has been explained. So over here, we are going to explain you how you can use large language model in an enterprise setup. So currently what happens is that every enterprise is going to have data in different formats. It could be structured, semi-structured, or could be unstructured data, just like random files. And how you can use them and start talking to them in a knowledge base application. So in the first example, we'll explain you how you can use a document and start talking to it. So first of all, over here is the architecture. So whenever you upload a file, that file basically goes to an embeddings model. That model generates embeddings and store them in a vector database, which is called a vector store. Whenever you ask a question, that question goes to that embedding model again, and the embeddings of your query is created and then searched against the vector embeddings stored in a vector database, and it finds out relevant chunks. And then those relevant chunks, along with your query, are passed to a large language model where it nicely summarizes and gives you a natural language prompt. So over here, I'm going to show you an example of how we are going to talk to a document which is about a 401k policy. Uh, Before that, I'll show you the file which I'm using, and if you see over here, this file is about a 401k policy, and if you want to talk to this file right now, you'll have to go through and skim everything about it. But over here, what you can basically do is that you can simply start talking to it. This file is loaded, and now I want to know how much does my company contributes towards the 401k policy. My company contributes to 401k, and it'll start creating embeddings of this particular question and start matching with the embeddings of the file which we have recently uploaded. So it told you 3%. Just compare before these large language models, what you would be doing. You will be going through that whole document, which is about 35, 40 pages, and then skimming through and finding the right information. So it's bringing you right information on your fingertips in seconds. Next, we have an example of a structured data set, which basically is, just think of an Excel file. So when you upload a file, it's going to get stored in any structured handling framework. And over here, we are using Pandas AI. Over here, the data is stored in a structured form in a Pandas data frame, and then it connects your question to the large language model and gives you responses. So for this example, we have a file which is about some financial samples, and let it load. So here you can see some top rows of it. It's about some company which have different segments, different companies, different products. It's units sold and sale price and everything is stored over there. And being a financial manager or maybe some account manager, you need to have some sort of business intelligence engineers who can basically tell you I'll run these queries on your SQL database and find things for you. Over here, what you can do, you simply upload a file and start talking to it. What is the total number number of units sold by each country. And I'll start finding the answer. So yeah, it's telling you Canada, these many, France, Germany, Mexico, United States of America. So these kind of capabilities are provided in an enterprise setup using a large language model. Next, you might have a SQL database, or it might be lying on a cloud service or maybe on-prem, and then you can simply connect it. And after connecting, you can simply start talking to it. Here's infrastructure over here. So again, we are using LangChain agents for SQL, which are connected to a database, and with the large language model. In our case, we are using an OpenAI model. So whenever you ask a question, it starts generating SQL queries based on that question using a large language model and run then on a SQL instance, and then finds you an answer and then summarizes, wraps it in a nice natural language prompt. So I have a database over here which is about a small company which is selling products, and it gets orders, and it has like some employees and some offices. So we can ask questions like, who is our most valuable customer? And it will find the result. So it told us like Euro Plus shopping channel is our most valuable customer with a credit limit of this particular amount. Moving further, maybe your data lives in a third-party cloud service, or maybe an instance where you cannot directly connect to it, and you have to make API calls to fetch data out of it. So here's an example of what we are showing is that we connected a large language model and then fine-tuned it to uh, write API calls for ServiceNow instance based on my natural language prompt. So we have a fine-tuned model over there. Whenever I ask a question, it turns my natural language prompt into a API call for ServiceNow, and then that call is made and then fetches response in JSON that is being passed to a large language model using LangChain, and it gives a summarized response from there. So for this example, we have connected our application with ITSM module for ServiceNow, and we can simply ask like, how many tickets are open? And it'll quickly fetch the answer, which is like, there are currently 139 tickets open. Furthermore, I mean, we have examples over here about your data living on a cloud platform. Maybe it's GCP, or it's Azure, or it's Amazon Web Services. You can simply connect them by passing authentication keys and connection strings in case of Azure container, or maybe your access key for AWS bucket, and it simply start ingesting the data. Your data will flow from different sources and get stored into a vector database, and then at the end you can again like similarly start talking to it using a virtual chatbot. So in this case, I'm not going to ask question, but I'm gonna show you like how a vector store looks like. So it fetched information from an Azure instance, and over here you can see like these are the documents, there are the IDs, and over here it is not basically presenting anything, but this basically are the vectors, and these are the documents which are basically chunks that were created, and finally this is the metadata, right? And this was about having files, structured unstructured data, and talking to it. Next, we'll move towards application of large language models in e-commerce using computer vision services. Yeah. So those are the filters which need to be provided before passing the data to a large language model. Those could be, some filters or maybe some, conditions applied to your ETL, where you are writing the code, how my data will be flowed, extract, transform, load. So that transformation has to be done in the pipeline, and then the defined data has to be passed to the large language model, where it will simply wrap and give you a natural language, like human kind of response. So over here from the architecture diagram, you just upload a picture, and then that picture goes to a computer vision model. In this case, we are using Azure Cognitive Services, a computer vision model by Azure, and then it extracts features and objects out of it, like what color is it, what's the text written on it, and based on that product, it's going to create tags and captions. That extracted information is then passed to a large language model, and that basically, when you provide a prompt to ask it like generate description for the product, it's going to generate description for that particular product. So here's an example. In this case, we have images of like shirts, and let's say I upload a picture of the shirt and give it a description like it's a t-shirt. So what it's gonna do is gonna take this image, pass it to a computer vision model, and from there it'll start extracting features out of it. Just think like a name for that product on your e-commerce platform. Blue shirt, color is blue, category is clothing, size of course it cannot tell, and it actually created a very nice and attractive tagline for your product, which you can simply post on your e-commerce platform. Stay stylish in this blue shirt featuring a comfortable fit with white, brown, and etc. Lastly, over here, I'm gonna show you a concept which is private GPT. Whatever we talked about was connecting your data to an closed source model. Mostly we were using Azure or OpenAI services, where actually your data, your embeddings goes to that model and brings responses back, which is like you are exposing your data. So private GPT is the concept which basically allows you to, there are two ways you can either download a model. There are like base model available. You can simply download the weights and then connect it with your generative AI application, or maybe you can try to train your model at home and then build your own model, connect it to the application, store your model in your firewalls with your embeddings living inside your firewalls, so that privacy is never breached. And then simply you can create endpoints and connect to your applications. That's pretty much it. And now I would like to pass this to Asif for the RP part.
All right. So my screen is now shared. I just have a single slide practically. And this is a use case of end-to-end automation for recruiters who are getting a ton of resumes for a certain position, and they want to shortlist them and see who should be invited for interview. And this automation will receive those resumes from email, download them, and do the complete processing. So let's see what it does. It will check emails, download the attachments, and if there are new attachments, it will digitize them, and digitizing the resume, it will load it to LLM, ask certain questions about the resume, like what is the name of the candidate, total experience of the candidate, years of experience on a certain technology the candidate has, skill set summary, career summary, and email address of the candidate. So, and these questions can be, of course, configured according to a customer's need. It based on a certain criteria already fed into the system, it will either reject a candidate or shortlist it for interviews. Once it has either shortlisted or rejected, it will update a spreadsheet about all the candidates who applied and what are what are these details about the candidate, like name, experience, skills, and the outcome of the decision about the candidate. After that, this automation, this bot will insert it, this candidate who is shortlisted into the legacy ERP, as well as if rejected, then even in that case, it will update that. Only the shortlisted candidates are updated into Salesforce as a lead, and an email is sent to both the candidates, either rejected or selected, about the outcome. This is all done by the bot by itself. Even the email generated by the bot for uh, to the selected candidates has a link through which they can schedule their own interview using Calendly. So that's the this loop goes on till it has more resumes to process, and in the end, the bot ends. So now let's see how it works. I have some resumes here in this folder. Of course, for this purpose of demo, I have sent myself these emails. And let's see, like, let me open one of the emails. I haven't written a lot of text, but you can see that each one has a resume. This one has my own. I will mark this one unread because the bot is programmed only to process unread emails. And what the bot will do is about some other demo. It will download the attachments into this folder and move the shortlisted candidate resumes to this folder. With both of these folders are empty at the moment. And it will fill form here about the candidate by itself. You will see it popping up on the screen for each candidate, and it will fill the form. And also it will call some APIs to insert the data into Salesforce. We will see that also in a while. So you can see there are some leads already here, but none of them are the ones through this system. We will have some more in a while after the bot runs. We can make it trigger through email. Whenever an email is received, it can auto trigger, but for now, I'm just triggering it through a click. Now it's in execution. You can see these resumes are downloaded here, and one by one bot will feed this one of the resume to the LLM at a time and ask certain questions that we need to know about the candidate, and then update the ERP as well as take the decision of either shortlisting or rejecting the candidate. Now, first resume is processed. It is picking the second one. And behind the scene where we cannot see it, how it digitizes it and analyzes it, we only see the part it manually does. I mean, when I say manually on the screen, but automated in by the bot. Sure. UiPath. This is UiPath. Yeah, go ahead. Very good question. So that relates to something that Mass said, that we have a limit of number of tokens that we can process, and the cost also depends on that. And if the files are bigger, we may have to divide them into chunk first before feeding them to the LLM. So we will have to do some more work before feeding that. Yes, we can make it do that. Yeah. So this is one of the last few candidates that it is processing. So there's a specified criteria built into this bot to look for experience of, I think, more than 8 years overall in the candidate and more than 4 years of RPA experience for this RPA developer position. That's why we are seeing some of the candidates are shortlisted and some are rejected by this bot.
Scanning only from the resumes, right? That is the only source.
Exactly. For now, it is only scanning from the resume. There can be enhancements in this bot to go look for this candidate on LinkedIn and scan that also for inconsistencies or getting additional information. But that's not part of it right now. Exactly. Yeah. There are like 5, 6 questions that it tries to figure out, like what is the name of the candidate? Second, how many years of experience this candidate has, how many years of experience on this certain technology this candidate has, and what other skills this candidate has, and an overall summary along with the email address of the candidate. So we can, of course, add more questions or change the prompt, and that's kind of a prompt, right? That's the what we want to know from this information. So this one is rejected. And the candidates selected or rejected here are um, just to show the capability. If there are actual names mentioned here, please don't mind. Because I downloaded some of the resumes from LinkedIn and some of the resumes that I had.
Yes, I think he'll be rejected.
Shortlisted. Why you thought she will be rejected? Right, right.
Honestly, like in Gen AI perspective, there could be, you don't know, right?
Bot doesn't know the race. Bot doesn't know the gender. So I don't think it should be should be biased about anything. We are not feeding that information to the bot. All right. Okay, I think we can stop the bot. It's taking a lot of time. Because there are too many cases. I think I'm stopping it for now and seeing that what happened. Uh, so this was the all right. So we have these 9 responses recorded into Google Forms with the details you can see here. Oh, it's coming up. Okay. So 25% were rejected, 75% were shortlisted here. And let me show you another thing. Let me refresh this Salesforce leads page. And we have these new leads here. And finally, I haven't sent those emails through the bot. I just created the drafts. So these are the drafts it has created to be sent to the candidates. And the shortlisted resumes of the shortlisted candidates are moved to another folder also. Thank you everyone who joined online.